Hello everybody, in this video we are going to solve another problem live from LeetCode's top interview 150 problem list. So far we have solved all the problems up to longest common prefix. If you haven't checked out my videos on those problems, please feel free to go to my channel and check them out. The next one is reverse words in a string and it is classified as medium difficulty. Well, let's read the problem. Given an input string S, reverse the order of the words. A word is defined as a sequence of non-space characters. The word in S will be separated by at least once. The words in S will be separated by at least one space. Okay. Written as a string of the words in reverse order concatenated by a single space. Okay, so that is interesting, which means we have to kind of do space compaction as well. Note that S may contain leading or trailing spaces or multiple spaces between two words. The returned string should only have a single space separating the words. Do not include any extra space. Okay, so yeah, I have done a problem like this a long time ago when during my first job, which is almost 20 years ago, when I was prepping for interviews. This used to be a common problem. So I have done it, but I have not done the variation with space compaction, right? And the algorithm now, I cannot unfortunately forget. Well, I do forget a lot of things, but this one I do remember, admittedly, which is the algorithm for such a thing is to reverse the whole string and then go through the string and reverse each word. So let me give you an example. Maybe you guys already know this and that's fine, but let's take one of the examples. So let's say the sky is blue. So if we are given the sky is blue, then we basically first reverse the entire string. So it will be EULB SIYKS. It is harder than I thought to type reverse. Okay. So the sky is blue. Yeah. So it will be first we reverse the whole string and then we go through the string and detect the word boundaries and reverse that much substring, right? So here we will detect the word boundary will be EULV and we'll reverse that. Then we detect the word boundary there, we reverse that much and then that much and then the, right? And you get your answer. But if we just do that algorithm, which I remember from back in the day, we will end up having a bunch of extra spaces, both leading and trailing extra spaces and also multiple spaces in the middle. So we have to kind of somehow take care of that. So we'll have to think about that before we start implementing. Like, yeah, in this case, for example, they have multiple in the middle, and in this case, they have before and after, and they have actually removed those in the reversed words version. Okay. Constraints are that the length of the string is between 1 and 10,000 inclusive, and string only contains English letters, uppercase and lowercase, digits, and spaces. Yeah, there is at least one word in S. Okay. Follow up. If the string data type is mutable in your language, can you solve it in place with O of one extra space? I think this is the algorithm that solves it in place. And yeah, that makes sense because 20 years ago when I was prepping, it was C++, right? And in that case, strings are mutable. And so yeah, I mean, this is the one you do it in place. You basically take the contents of the string, you reverse the whole string, and then you keep reversing each one. Okay, that makes sense. But like I said, we will have to figure out the way to do space compaction. So how do we do that? I mean, there are a couple of ways that come to mind, right? So let's take an example that does have that. So let's take, this time I'll include double quotes. Let's take an example where it's both. There is a couple of spaces before and multiple spaces in the middle and a couple of spaces after, right? And in this case, we actually have to return world and hello like this, right? Okay, so there are a couple of approaches we could take. One approach is that when we reverse it, we do a little bit of a smart reverse, right? Which means we kind of start canning and see, okay, let's just not even copy these things. Okay, so in this is our end result, right? So I'm going to make some space for, okay. So we could actually reverse a bit smartly, right? So we could say, okay, we are not going to copy these trailing spaces. We'll go from right to left and say D, L, R, or W. And similarly, we could also compact space right away, right? And we could just copy one space. And we need to figure out how we do that. But I mean, just a simple state keeping should help us do that. And then we do same thing here, O, L, L, E, H, right? And then we do the same thing like we did before, and we will get this, right? World and hello. Okay, so that's one thing. The other thing we could do is, I mean, and this would work, and maybe that's also a better approach, but let's see. The other approach that I have thought about just now is that we take this and we continue with this with our original algorithm, right? Okay, and we just say, okay, we'll just do space compaction as the last step, or yeah, as the last step, right? So as a post-processing step. So what will we do? We say there are two spaces. We'll keep on doing that. D, L, R, O, W, three spaces here, and then O, L, L, E, H, and two spaces here, right? Then we still continue our algorithm. We detect the word boundaries and we reverse those words. So we'll say world and hello, and then we basically just do space compaction as a single step in place by using the technique we have used before, like removing duplicates in an array or something like that, right? Where we can keep a destination pointer within the same array, and we can actually just copy that. So world and hello would be from this to this. So we could do this, right? And while this appears to be a little bit cleaner, like the number of here, it appears to be one more step, like you see here. I mean, here the first conversion to me is actually very tricky, in my opinion. I mean, we can do it, but it will be very complicated code to understand and maintain. So I'm just going to go with my gut feel and just go with this approach. So let's see, what else do we need to figure out? Well, we have kind of done all the components we need in other problems before. So for example, detecting word boundaries, we did it in a problem we recently did, where we did a problem on this channel saying return the last word in a string. And there we went from right to left, and we kind of detected when spaces end and when the word starts, and then when again space comes with a state variable. So we'll do the same thing. Reversing is just a helper. We are doing multiple reverses, so we are definitely going to write a helper for that. And space compaction also, like I said, we have done in other problems on this channel, like removing duplicates from an array in place, and merging two sorted arrays in place, like in the first array, and so on. So if you haven't checked out those problems, feel free to, but I will still explain as I write the code, so you don't have to check them out before you see this. Okay. So with that, let us actually, write the reverse helper first, right? So we need to reverse in place. So the return data is void, and we will reverse chars in a char array, right? And we'll be working with char arrays because strings are immutable, right? So char a, let's just call it a, int left and int right. And we'll be reversing inclusive of L and R, right? Both limits are inclusive. We could define the right limit as exclusive. It doesn't matter. I think it's a private function. We have to call it correctly, right? Okay. So what do we do here? We say while I think L is less than R, and ch temp equals, not ch, char temp equals a of L equal to a of R, and then a of R equal to temp. So that's a typical way to swap. And what we do is we say plus plus L minus minus R, right? And we keep on doing this until they cross or become equal, right? Then we don't have to swap. Okay, so that's our reverse helper. And since it is inclusive of L and R, yeah, we are reading at R as well. Okay, so that works. Okay, so now we have a reverse helper. Now let's follow our steps, right? Let me take these 4 steps here actually. So we are following this, right? So let's take that in our implementation below here and add a comment. Okay, there. Okay, so what are we doing here? So first let's convert S to a character array, because like I said in Java, strings are immutable, so we have to do s dot to char array. That will create a new array, copy the contents of the string into that array, and this is the array will work in place. So we kind of are doing their follow up, but after we convert S to a char array, right? Okay, so now we first reverse all the characters, right? Like we said, that's our first step. They take this hello world with a bunch of spaces and do this. Okay, so we will call reverse chars on s chars on 0. Actually, I'm going to do one thing here. I think we are going to need this again and again. Final int n equal to s dot length, right? And we'll say n minus 1. Okay. So that's what we are reversing the whole string. So now we have this string here. Now we are going to detect word boundaries in that string and call our reverse helper for those word boundaries. So, okay, so what do we need? We need the start of a word. So W left. Initially that is -1 because we haven't yet started a word. I think that might be all because the right limit will be found as we are looping. But the left is kind of somewhere before. So, okay, so int equal to 0, I is less than n plus plus I, right? So we are going from left to right in scars, which is now reversed, by the way. And we are trying to find a word boundary. So first, let's get the character at that index from scars. So scars of I. So that's the character. Then let's see if it is a space. If it is a space, and this is a similar approach to what we did in that other problem I said of returning the last word from a given string, right? So we say ch equals, and we are only supposed to handle one white space character, which is the space. So we can just do that. Okay. So now we have what we need, and we would have been inside a word if w left wasn't -1, right? Okay. So we say if w left equal -1. Then what does that mean? That means we are already inside a space, right? And if that happens, we were in space, but now we are not. The previous character was a space, right? And right now we are not in space. Okay, so if not is space, that means we need to start the word, right? So w left equal to I, right? We were in a space. Our previous character was a space and current character is not a space, right? So then we start the left of the word. And do we do anything else? No, we don't do anything else, right? And else, which means we were in space and this is also a space. Okay, so in else we don't do anything, so that goes away. And in this else, this is where we are. Let's write it down here, right? We are in a word, right? Previous was a space, so in space, right? That sounds cool, in space. Okay. Okay, we were in space and we got another word. So start not space, start the word, right? This is in a word. And then we go here and we say, yes, if it is space. We were in a word and we got a space, which means we detected the end of a word, right? So we write that down here. Let's say is space end the word, right? And end the word means we are going to do two things. We are going to reverse the word and then we are going to again reset w left to -1, right? So before I forget, let me do that first. But before I reset the value of w left, I do need to call our reverse helper. So we say reverse chars on s chars w left, words left, and the right index is I minus 1, because remember we are already now at a space, and so the previous character is what we need to end at, inclusive, right? It's inclusive. Okay, so that's that, and then we reset the word left because we are not in a word anymore. Okay, in else here what happens? Do we do anything here? So we are in a word and we continue the word, so we don't do anything here, right? Yeah, so we don't do anything here either. Okay, so that is that. Let me see, is that like, okay, so I think this reverses all the words, so this is reverses all words in place. Oh yeah, okay, so there is one issue here, right? I just realized. Okay, so the thing is we are going to reverse the words only when we look at the next space, and the problem is if it is the end of the word, end of the sentence, and there's no next space, then the last word is not going to be reversed. Okay, so this is an issue. Okay, so how do we fix it? Now we could always add a special thing at the end. I always try to avoid that because that tends to have some edge cases. So is there a way to just leverage the loop? Actually, one thing we can do this actually. Let's simulate that there is an end space, right? So let's say if we will go one more, we'll do I less or equal to n, but here we'll say if I is less than n, then we read the character from the array, but otherwise it is a space. Okay, so I think that will take care of this. If there is already an end space, it doesn't matter, right? Our algorithm takes care of multiple spaces and so on. But if there isn't, this kind of simulates that, and that's nice because then we don't have to handle the last word specially. Okay, so that now reverses all words in place. Sounds good. I would generally in production code add a comment here like less or equal to n, like why are we doing this? But I'm going to skip that for now. Okay. Now we do compaction, right? So here we do space compaction. Compaction in place. And this is very straightforward, right? We have done something like this. We do a destination pointer within the same array, which we are compacting. And we say int I equal to 0, I is less than n plus plus I, right? Yeah, here it's less than n. I was thinking it was less or equals, but here it's less than. And now we don't have to simulate. And now we just say, okay, so we do need that is space thing here because that is what in space equal to true. So we simulate that initially there was space on the left side so that if there is any leading spaces, we'll get rid of that. And the reason is we'll do the same thing here. Char ch equals s chars of I. Everything is happening in place in s chars, right? And we say boolean is space. I mean, there's one is in space, one is in space. It's not ideal. They differ very slightly. I would in reality give them a little bit of more different names, but for now this is going to be fine. I'll just be careful now. Okay, so equal space is that space. Okay, so what do? We say if we were in space and we saw another space, then we don't want to copy that, right? Like into the destination pointer, and we want to skip that and go to the next character. So that makes sense. And in every other case, actually, before I forget, we need to do this. In space has to be reset to whether the current character is a space, right? Okay. And now for every other case, we copy to the destination place, right? So we say s chars of dest equals s chars of I and plus plus dest. Okay, so that's done. Now one thing this will not do, it will not get rid of the trailing spaces because again the way it compacts spaces, it allows one space. Now leading space, we tricked it by thinking that there was a space before leading, but trailing again I don't want to add extra special code if I don't have to, right? So we need to figure that out. This won't remove it. Well, I think one thing we can do is when we convert this character array into a string, we can just at that time remove, and remember it will only maximum add one extra space at the end, right? So what is our length of the string? It's going to be destination, right? Where destination stops. But that will be one less than destination if we have a character, a space at the last index, right? So which means if this is what I'm thinking. So s-chars of dest minus one equal space, then you do dest minus one as the length, right? Otherwise you do dest as the length. And this is length of the string that we have to actually get the substring of in s-chars, okay? And now I need to, I don't remember in Java, create string from array with indices. I want to create a string in Java string with an, okay, that I did not write that very well, I guess. Okay, let me try it again. Create string from character array, right? Char array, yeah, this one. No, I'm not looking for that. Sorry about this. I should know these things, but I okay. Let's do this one and see what it's saying. Oh, no, no, this is also not what I'm looking for. I think there is string dot value of, which is generally used to convert a character array into a string, but let's see if that takes indices. Okay, so show me the signature, that's all I need. Okay, so oh wait, there you go. Offset and count. This is exactly what we need, right? So I think what we are saying here is we are saying return string dot value of the char array is as chars, offset is 0, and the length is dest. Sorry, not dest, length, right? Yes. So that is what will get rid of the last space. Let's see. Let's run this. I would have manually run the thing, but I think it became a little longer than I thought. Okay, there you go. So it did work. The sky is blue is the easy case where there is no extra spaces. This one has extra spaces here and here, but not in the middle. And this one has an extra. Okay, so that's good. I mean, we could add the case we did, which is add extra space everywhere, right? So we could say let's try this. It should work, but just to okay. So case 1 was also accepted, and blue is sky the is okay. So let's try to submit this. That will run bunch more test cases. Oh, cool. So it got accepted, and we beat like 98.5% people in time, 98.74% in memory. There you go. Hopefully that was straightforward. Yeah, such problems like, I mean, it did take a little bit time, but you know, it's good to be meticulous, go step by step, and you know, make sure we got every detail right. Hopefully that was helpful. If you're liking what I'm doing on this channel, please consider subscribing and hit that thumbs up button on the video. That really helps me a lot. See you guys next time.